Hi guys! Today we are going to talk about one of the most misunderstood rules in the whole React ecosystem. And I'm talking about the rules that you cannot change the state directly. You're only allowed to change the state using setState function, and while doing that, you are not allowed to mutate or to change the old state, right? If you have been programming React for at least a couple of weeks, you probably saw this rule already, but in all those online tutorials, videos, and courses, they tell you about this rule, but they never care to explain what will happen if you violate that rule. And will something ever happen at all? In fact, I have several comments from students saying, you know what, well, I know that you're not supposed to change that state directly, but, you know, in my application, I just changed the state, I updated state object in my code directly, and you know what happened? Nothing changed. My application just works in a perfect way, exactly like it was working before, so does it make sense at all to follow this rule or not? Because honestly, this rule adds lots of headache, because the operations that used to take just one line of code, like updating the object that is inside of an array, just one liner in the normal JavaScript, all of a sudden in React it becomes a whole different story. It is now, you now need to take care to copy the array, you need to take care to copy the object, and only in those copies you are allowed to update the value of the attribute, right? So why this rule is in place, and do you always have to follow it, or maybe there are some issues where you can just not follow that rule and update state directly? Time to figure out.
In order to understand a little bit better how React internally works and how it updates the application, I have created this very simple, very typical React app that resembles thousands of other very typical, very simple React apps, right? So all this application does, it manages this little collection, item A, item B, and item C, and you can click these buttons A, B, and C, and then the corresponding item will receive a new random value, right? So this whole application is made of three components. There is a collection container that is managing the data, there is a collection view, and there is an item. And also there is one more property that is called otherProp that is outside of a collection view. We'll see why is it important to have this property later, and we'll see how it impacts the rendering of the application. And obviously you can also update this property just like the other ones, right? So a very simple app and a very simple code structure as well. So at the top level, we have collection container, and this is our state. So the state is having a single object called data with properties A, B, and C, and there is an otherProp, right? Update data is the heart of update logic. That's what this whole video is about. How do we update the state, and what will happen if we update the state in the wrong way, right? So what this function does, it takes the key as a parameter, it just creates a random value, and then it assigns this random value to the correct key A, B, or C. And right now this function is working in the correct way, meaning it does not change the old state as per React's recommendations, right? So we are creating the new object, and inside of that new object we are replacing the key with the new value. At the same time, the old object remains intact. However, there is another bit of code here that we will uncomment in a second to see what will happen that actually does the bad thing. It updates the old state through updating the data, which is the part of an old state. And we'll see in a second what will happen once we uncomment that code, right? So collection container, and then there are a couple more components here, collection view that renders the view, and each individual item is rendered by an item component, right? So now let's go back to collection container and do the bad thing. Don't do that at home. This bad code is written by certified professionals. So anyway, so right now this is the incorrect, the bad way to update React state. We are updating the old state. Now let's go back to our application, refresh it a couple of times, and look how it works. And from what we see right now, this application is not broken at all, right? So whenever we're clicking the buttons, we see the updated values, and everything is fine, and everything is working properly. So now the big question is, does this rule that you should not update the old state, does this rule make sense? Because from what we just did, it seems like, well, it doesn't really matter if you do update old state or if you do not update old state. All right, but let's not jump to conclusions too quickly. Let's comment back the bad code and uncomment the good code. And now what I want to do, I want to check out which parts of this application will be updated when I'm clicking one of these buttons, right? And in order to do that, I have here a little bit lines of code commented in the collection view. Yeah, here. I am changing the background color of a component to a random color each time when a render method is called, right? So this will be my way to know that this component has been re-rendered. And I'll do the same for the items. So now, if I update the application, you see the colors are jumping like crazy, and I will immediately see that a certain component has been updated because the color of that component will change. All right, so now let's check, guys, how well you know the rendering of React, how rendering works in React, right? So I'm going to click A button that will set just a single value, the value for item A. So can you guess now, or do you know, guys, which parts of the application will be re-rendered, right? Will it be the whole application maybe, or just the collection and item A, or maybe only item A without the collection itself, right? So give me your answer in the comment and we'll see how it works, right? So ready? Your last chance to put your answer in the comment. All right, I'm clicking it. So I'll click A. And as you see, everything has changed. Let me click it again so you see the change in the colors, right? Every color is changing in the collection itself, the item that is updated, and other items as well, they are being re-rendered. So if you continue this experiment, you'll see this wild color jumping, right? All right, even though it might seem like a very unoptimal algorithm, this is exactly how React works. So whenever you're updating something in the data, something in the state, the whole tree of components downstream, down in the hierarchy will update, right? And you might ask why React is working this way. It doesn't seem like good algorithm at all. As much as it seems to be an unoptimal algorithm, this is the way that React works. And in React, it is considered to be not a slow operation to render, to call this method to render a component. What is considered to be slow then is to take the resulting markup and put it in the actual page. So actual page manipulation is slow. Rendering is considered to be not slow. And for React, there is another step. There is a reconciliation algorithm that takes this markup that you return from render method and it compares to the old state that is currently present on the page. And if there are no differences, then React will skip the update phase and it will not touch the page at all. And that's why it will be quite fast, right? All right, so now let's test your knowledge of React once again, guys. And now I will touch the property that does not participate in rendering of this collection view. So we do not pass the other property to a collection at all. It stays on the level of collection container. Now, give me your guess. Will collection change or it will not change? So I'm clicking update other prop. And as you see, even though this property does not participate in rendering of this collection, it still updates the collection. For the same reason, we updated the state on collection container and all the components downstream, down in hierarchy, they are updated. No matter if they will actually receive new data or not, they will be updated. All right, so that might be okay for a small application, but let's consider that you might be building something like a ticket booking application for a stadium, and you have loads and loads of components on the page, or there is a table with lots of data, and you might not want even to call the render function without a reason to do so. And this optimization, it's quite popular in React, it's quite common, and for that there is a specific lifecycle hook in React that is called should_component_update. And in this method, it receives the next props and next state, but we don't care about the next state, we only care about the next props, right? So if you return true from this method, it means that the component should really update, and then React will call render. But if you return false, render will not be called. So in this function, we can do the very simple thing to tell that if next props data is not the same as this props data, then we want to re-render this component. Otherwise, we want to skip re-rendering. All right, so we add this lifecycle hook, we go back to the application, and now let's click the other prop, and you see now it's magic, right? Now our collection view is not updating anymore. At least we saved whole update of the whole hierarchy of components when we are clicking on the property outside of the collection view, right? It still will update all the components when we're clicking here because the data is changed, but we can also improve that performance a little bit, right? We can go to item A and implement kind of the same optimization technique, right? However, here is a little problem. Our item is not a class, but for the functional components, there is a higher order component that's called memo that is in standard React. And let me just make the screen a bit bigger. We can write like this, memo, and wrap our component in this higher order component memo. Memo will work exactly in the same way as should component update with this kind of a check. It will check all the properties, and if any property changed, it will update the components. Otherwise, it will skip the update of a component, right? If we go back, now if we click, let's say A, you see only A has updated. A and the collection view. Same for B. We see the item A and item C is not changed now. Only the correct item is being updated. All right, so this is a huge progress, right? Even in React, there is one more feature that is called the pure component that does exactly that. And then you don't have to implement should component update because pure component works exactly like the normal component, but it also checks that the data has actually changed before calling re-render. All right, so guys, I know that the subject of this video was slightly different. It was about the state updates, right? But I promised to you I'm coming there, right? So now let's go back to our container and let's uncomment the bad code, right? The thing that you shouldn't be doing at all. So we are changing now the old value in the old object instead of doing this nice code and providing the new object with the new state to the set state. So what will happen now? Let's refresh the application and I'll click a couple of times. See? You may be even hearing it on the mic. I'm clicking the button, but it doesn't work. It doesn't update anything except for the other props. So the collection itself is not updated. So what happened here? Why our application is now broken and nothing is updated at all, right? And the reason is that now collection view is a pure component, and a pure component will compare its old properties to the new properties to decide whether it needs to update or not. And with the careless update of a properties, there was a careless update of the state that we're doing here, and this state will become the properties of that component, right? What we're doing, instead of creating the new object like this, we're modifying the old object, and inside of that old object, we are changing the key. Now, when the collection view that we just optimized, that we created as a pure component, when it will start comparing old data, this props data with the new props data, it will see that it is exactly the same object. So there is no difference. And that again happens because we updated it here in place instead of doing it properly through the set state. And because we broke the old object, the comparison tells, all right, we have exactly the same data, even though in fact the data has changed, but this component, this collection view doesn't have a way to tell that this change has happened because the old object is now broken and it is exactly the same as the new object. So collection view is a pure component and it says there is no reason to re-render because the data hasn't changed. Now let's complete this experiment by commenting back the bad way to update the state and uncommenting the good way to update the state and make sure that our application is again working as it is supposed to work. Right, see, when I'm clicking B, only the item B is changed and the collection view itself is changed, right? So the other components are not changed. And that's due to the fact that those are pure components, and pure components work very well if you are updating the state in a proper way.
So this example that we just saw, pure components, is just one example of what may go wrong if you start updating state carelessly and start changing the state object directly. Because when React propagates the object downstream, right, down through the hierarchy of the components, it doesn't create a deep copy of the object, right? It's just simply too expensive, too difficult operation to create a deep copy of an object. So the objects that are passed in between the components, they are actually shared. So the object that you see in your component that you're going to update right now, it actually might be used by the other component somewhere in the other part of the application. And if you carelessly update that object, then the comparison logic, the logic that compares the old state and the new state, state, for example, it will most definitely break, right? So let's summarize. In React world, immutability is a feature that is extremely important for determining which parts of the state have changed and thus which parts of the application should be updated now. And it is only possible to do so if the old state have not changed. Otherwise, the comparison will simply not work, right? So guys, I hope that this video helped you a little bit to understand this inner mechanics of React and why exactly is it so important to keep old state intact and why this whole immutability thing matters for React. And of course, if you have any more questions left, please do not hesitate to put them in comments. And if you like that video, press that like button and subscribe to this channel. That motivates me a lot. Thank you very much for watching and see you in the upcoming videos. Bye!